So now let us move on to the RC circuit problems. So far we discussed about the RL circuit. Now let us discuss some RC circuit problems also quickly. So here a voltage of 35 is applied across CR series circuit. CR or RC, both are same. It doesn't matter. So let me take a R resistor and a capacitor. So how much voltage is applied? 35 volts. So next, what we need to do? If voltage across the resistor is 21 volts, this is the resistor, this is the capacitor, but I want to show in frequency domain, this is minus j xc, minus j xc. And they clearly stated that voltage across the resistor is how much? Tell me. To- So indicate that across the resistor, this is 21 volts. Across the resistor is 21 volts. Next, what we need to do? We need to find voltage across the capacitor. So let me indicate that this is VC. Try to see that I'm putting magnitudes only. I'm not putting any bar over here. If I'll put hyphen bar here, it becomes phasor. If I'll remove it, it is magnitude. That is the meaning. So now here again more or less the same kind of phenomena from the phasor diagram you can get quickly here. So now I don't want to draw the current, just I will put up the things as like this. First let us say current is in phase with the voltage. This is the resistor voltage and current also in phase with this. So let me put as just for time being, later on I will not show the current, just these things. This black color one is the current and green color one is the resistor voltage. Resistor voltage. And we know for a capacitor current should lead the voltage. Do you remember that expression? Current should lead the, this is VR magnitude. So this is current magnitude. Which current? Total current magnitude. So where is the total current? Here is the total current, I phasor. Now where should be the voltage of the capacitor? Capacitor voltage should be downward, so that now current is leading the voltage. So this is what the VC magnitude. VC magnitude. See the importance of phasor diagram now. So, but to get some things clear visualization, I will put up this VC at the tip of VR. Both are equivalent. Now, the phasor sum of VR and VC is the total voltage, resultant voltage. So, that is what the source voltage. This is the source voltage. How much is that? Here it is given Vs magnitude. Vs magnitude is given to you. Now again from the simple principles, a right angle triangle this also. So now can I put the things as like this, as what we had seen? Vs magnitude square is equal to hypotenuse is equal to Vr magnitude square plus Vc magnitude square. Now you find the unknown, very easy. So now what is Vc? We need the capacitor voltage. So Vc is equal to square root of Vs square. How much is the Vs? 35 minus Vr square. How much is the Vr? 21 square. I wrote the answer directly. How much is this? Somebody tell me. 35 square minus 21 square. 28 volts. Yeah, fine. 28 volts. So see the importance of phasor diagram, that should be on the tip of your fingers. So you should be very careful about the phasor diagram. So next is the second one. A resistance of 50 ohms is connected in series with a capacitance of 20 microfarad. So draw the diagram again. That statement I will put in the form of diagram. There is a resistor. Next, I want to add this in series with a capacitor. So I want to put up the capacitor. So next, what happened? If a supply of 200 volts is connected, so this combination is connected across a supply of 200 volts. 200 volts. And just I want to highlight one point about this supply in the previous problem, that sorry, 200 volts. Yeah, fine. So just see here, they said that a voltage is applied across the RC circuit. They did not said what kind of voltage is this. So if it is not specified anything, it is treated as AC supply only. If it is clearly given that it is a DC, then only consider DC. One thing. Other thing is that they did not specify about the magnitude. Is it RMS value or peak value? So until unless it's specified as peak value, so we will consider generally as RMS only. So it is supply is AC, given value is RMS. This is by default understanding in AC systems. If it is not given any information, you should treat that it is AC supply, the given value is RMS value, and it is only magnitude. Right. So now let me put up these values here, 50 ohms, and next what else? So this is a 20 microfarad. Just I want to make in this way, as it is frequency domain minus jxc, but I'll write jxc or xc here. Xc is equal to 1 by omega c, or 1 by 2 pi fc. How much is this value? Can you tell me? 1 by, substitute all this, 2 pi f is 100 and c is 20 into 10 power minus 6. How much is xc? Quickly. 1 divided by 2 pi 100. Yeah, 20 into 10 power minus 6. 79.577. Is that clear? Everyone got same thing? 79.577. What are the units? Ohms. So now here, can I put up this as minus j 79.577? If it is directly given as xc, I would have written, but they did not given. They given only capacitor. So I calculated xc and I had put up those things over here. Now simple thing. First question is that circuit impedance. What is the circuit impedance? This is a series circuit. So circuit impedance is inductive impedance plus capacitive impedance. How much is the inductive impedance? 50, plus capacitive impedance is minus j 79.577. And what we need exactly is magnitude. So, or we need polar form. So can you put up this in polar form? 50 minus, so 79.577. So I, then your answer should be in the polar form in your calculator. So this is 93.98 at an angle of 57.85 degrees. Now the thing is, impedance means we need the magnitude of the impedance is 93.98 ohms. This is what the answer. Next, what else we need? The current flowing. So current means I need only current magnitude. So for which just previously we had seen current magnitude is equal to voltage magnitude divided by Vs magnitude divided by Zt magnitude. So Vs magnitude is known. How much? 200. Zt magnitude is just we calculated 93.98. So how much is this? 200 divided by this one 2.128 amperes. What else we need? Phase angle between voltage and current, for which so one can directly put up the things or just you can see in this way. So if let let Vs phasor is equal to Vs phasor is equal to Vs at an angle of 0. What is Vs is 200 at an angle of 0. In this way you can assume, or you can assume current as the reference, you calculate the voltage angle, either of the way. So if you means think above all these things, you can try to observe that previously we did this thing, phasor diagram. So this is an RC circuit, sorry, this is amperes, this is an RC circuit. See, in RC circuit what kind of phasor diagram we got? Just now we drawn, so this kind of phasor diagram we get. So let me put up this diagram over here. Just I'm putting that diagram over here. Now, what is the theta? So you can observe theta is the angle of the impedance. So here theta is the angle of the impedance as like this. So theta can be written as tan inverse of xc by r, xc by r. That is imaginary part divided by real part. That is of course tan inverse of minus xc by r, or that minus is already considered in clockwise, so it is tan inverse xc by r. So what is xc? So you can write the same thing as tan inverse of, so opposite side is vc magnitude divided by so vs magnitude. So in this way, in many ways you can write up. So above all these things, the ZT we already calculated as 93.98 at an angle of how much is that? Minus 57.85. So this is what the theta. You no need to put any effort, just directly you can blindly think of that. This is the theta. So minus is considered already over here in the clockwise direction. So now theta is equivalent to 57.85. One can directly put up like this.